Okay. So I think it's up on the big screen. And I really can't see anyone due to the bright light here. But I think there are some people. Yeah. Okay, cool. Welcome, everyone. Great to see so many attendees on this year's NDC. A huge shout out to the organizers and the volunteers and the sponsors for making this happen. Would definitely not be possible without any of them. So my name is Hans Kristian. I'm 29 years old. I have a wife and 2 boys back in Bergen, the western part of Norway, for those of you who are not local. Yeah, and they're a huge part of my life, and I just want to take the time to say thank you to my wife, who takes care of the kids and all of the things back home when I'm out traveling and at NDC. So previously, I used to be a software engineer at the Norwegian Tracking Association, DNT, where I were responsible for their open data platform and for ut.no, for those of you who have been hiking. I know they recently launched an updated version, and I have some friends over at Shortcut that made the new mobile app, so be sure to check that out afterwards. And if you're planning your summer vacation, that would be a great tool if you want to do some hiking in Norway. Or if my talk gets boring, then you can browse there and see something. So I joined every 3 years ago. I went from 30 colleagues to 9,000 colleagues. That was kind of a cultural shock. And if you guys followed at least the Norwegian tech news, Every and Tieto announced their intention to merge during the year. And after that will be the largest IT organization in the Northern Europe. So I started out as just a consultant within Every, and quickly realized that the practices we were doing at the Tracking Association, where we were a very small team, were not that much being practiced within Every. So I took upon it myself to proclaim myself as the DevOps practice lead, and after a while, people started referring me to as that, and a while after that, it was formalized that I had that role and could spend a lot of my time working internally and working with our customers, how to kind of use the DevOps practices and methodologies. I'm also an avid open source contributor and enthusiast, been on the Node.js Foundation, been helping them with build and deploy, and if anyone of you are Node.js users and Docker users, I've been part of the team creating the official Node.js image. So today I'm going to talk about a project we've been working with for the last couple of months, last year actually. It's called Builderbank, and I'm going to give a brief introduction. What is Bulder? What is it actually about? The architecture behind, jumping right in and digging into what does it take to make a new mobile bank. Then we'll talk about build and deploy, as well as runtime and operations. So, Builderbank is a new challenger bank for all of Norway. It's a mobile-only bank, so we won't have any traditional desktop website where you can log in and do your banking things. It's owned solely by Sparebanken Vest, but it operates otherwise completely independently. It's completely autonomous, has its own leadership, its own developers, its own technical staff, support staff, and so on, and reports directly to the CEO of the parent company. Yeah, so the kind of like the differential factors here is to create the best and the most awesome mobile experience for banking customers, competitive mortgages with automatic rent adjustments. So no need to call your bank and ask them to set down the rent. If it's been changed, this should happen automatically, and we believe that customers shouldn't have to like call their banks every now and then to get the fair rate that they deserve. And then delivering value adds and integrations on top of the traditional transactions and payments and what you are used to in normal banking situations. So the timeline was this. August of 2018, Bulder Bank was just an idea, where the head of the bank went to the corporate, the board of directors, and proposed an idea to create a challenger bank. And keep in mind, this was the idea, and the reason that this was kind of like proposed at all is sort of the PSD2 Open Banking Directive that is going into effect in September. But he got approval and started assembling a team. And during the fall, we had the team in place. And by January, it was in full effect. And then by June 3rd, we launched. And that's only 10 months from going from just an idea, no code at all, no specifications, nothing, just a date and kind of the overall realms that what are we going to build here. And I must say that I've never been on a product where in this kind of like industry at least, that where we were able to pull that off. So the only way we could have achieved this was to scope down, and only deliver a minimal viable product, a truly minimal viable product, which means that, of course, since we were mobile only and we we shouldn't have any like manual procedures and calling in and yada yada yada, all of the onboarding had to be done on the device, on the mobile phone. Then, of course, you need to show your transactions, your banking histories. You need to be able to do payments. You need some management of your credit cards or payment cards. And then we also had push notifications for when there are new transactions or there are anything exciting happening. And also invoice scanning. So you didn't have to type in the KID number and account number and so on. You could just scan your invoice if you still had paper invoice. So this was the feature set that we launched in with June 3rd. And during the summer now, and until we are open for everyone. So June 3rd, we opened for our like beta customers. We have a waiting list, and we are onboarding 100 customers at the time during the summer. But in September, in the fall, we'll open for everyone. And at that time, we are working on subscription management, working on much richer transaction details, where you can really see what are the transactions and payments about, not only a cryptic name and what's in a normal bank statement, and also tools to help manage your economy. So this was the team. In reality, they probably looked a little bit more like that. We have a CTO. We have 2 people doing primarily UX and design. We have a front-end developer. Since we only have the landing site, we don't have that much front-end developer. We have 2 guys doing backend development, 2 guys on infrastructure. We have an Android team and an iOS team, and that's it. this is the complete technical Builder team. But it wouldn't be possible for all the work that Sparebank Invest, the rest of the open banking and PSD2 team there has done, because we are building on top of or building against their APIs, banking APIs, in order to do the core banking functionality, and I'll get more into that. So these are the key principles. So our new CTO was very vocal when he started that these are the principles that we are going to work within. We want to empower people. Everyone on the team should have their say and be able to, like, if they want to take charge on a functionality or on a feature, they should be able to do awesome work, so make people awesome. And the second part was make it okay to fail, make it safe to fail. You should, in order to kind of do experiments and go fast and lean and rapidly, we do need a safety net, and there's never like one person at fault if something goes wrong. It's always the team that wins or fails. We should strive to experiment and learn rapidly. So coming up with new ideas, putting that into effect, and getting feedback, and then deciding whether or not we should go forward with this. Not sit down in a committee and design and kind of think long and hard of if we should do this or not. And that's also in line that deliver value continuously. It doesn't matter if it's the most exciting and best feature in the world. If no one is using it, it's potentially just sunken cost. So it needs to be done in an iterative process and always be releasing functionalities when they're done. So scoping down, making the features as small as possible, and then getting them out the door. So here are the latest stats leading up to our release June 3rd. As you can see, so on the left-hand side, you have the number of commits, total in the organization, and then you have repositories for different components and subsystems. So as you can see, it kind of like grows and grows and grows at a steady rate until June, and we are expecting this to kind of like flatten a little bit out during the summer when there are vacation, but continue during the fall. So this, if we rewind 10 months when this was just an idea, our CTO Torvald came to some of the guys and with this idea. He had kind of like got accepted that we were building this bank, and he had got the date 31st of May or beginning of June back, that it had to be done by then. It had to be ready there and starting onboarding new customers to bank. And he asked, how is this possible? Can we do this in 10 months? And if so, how? And what he got back was that, yes, we believe this is possible if we are using Google Cloud. And I'll get into why, when he got that answer back, within 6 weeks, we had made a notice to Finanstilsynet that we were going to use Google Cloud and set up, and we're starting to work. And he said to me that having a deadline like this forces the technicians or developers to think new, and it also forces the leadership to listen. When they say this is how we need to do it, they need to listen to that and take the appropriate decisions. So why did we choose Google Cloud? There are two reasons. The first one is Firebase, which is a mobile app developers suite of products by Google Cloud. And the third one is their managed Kubernetes offering. So the current architecture, or the architecture, is quite simple. We have mobile devices, we have Android and iOS applications, or bank applications for the bank. They are talking with Firebase, so they get all of the customer data from Firebase, customer information, transactions, accounts, credit cards, you name it. Everything is stored there. And whenever they want to do a new transaction or they want to update some of their information, that is written back to Firebase. From Firebase, then it goes into our backend systems, which is running on Kubernetes engine. And then again, we talk with the open banking PSD2 APIs at Sparebanken Vest. So Firebase can be kind of divided in 3 main categories, at least the products we are currently using. So we have Firestore, which is their NoSQL database for mobile and web applications. Fun fact, during most of the development of the bank, it was in preview. And just in time for release, just a couple of months before we released, it went out of preview and into general availability, and we got SLA. So that was fortunate. So also it has cloud functions, serverless functions that triggers whenever if anything is updated or deleted or inserted or anything, we can trigger functions and do something with that. And then it also has its own authentication system, so we don't need to deal with how do we securely authenticate the user with the Firebase service. That is all handled for us. So for a little bit more operational side, it has what they call Crashlytics, which is a crash reporting tool. So whenever there's an error in the application, that gets automatically reported, and we get nice dashboards and alerts and root cause analysis. Performance monitoring, how is the client, how are they experiencing the bank we have built. And also there's like a test lab where you can test new functionality in a headless way and before it's released to our customers. And the third one, it comes with its own messaging system, so it enables us to deliver push notifications and in-app notifications without having to deal a lot with any infrastructure. It's just an API. Analytics for getting metrics and data for all of the usage, and also remote configuration where we can do A/B testing, push different configurations to different set of users, and turn functionality off and on. So the Firestore works like this. When we started setting up the project or creating these applications, so what would have typically taken us a couple of days, weeks, months maybe to set up like a backend where we can communicate and start getting data and writing data back and getting that performant and secure and all of that, that was done in 30 minutes. So Firebase provides us the SDKs necessarily to do a bidirectional communication with the Firestore. So we can instantly get all of the data that for this particular customer, and we can just write it back, and it all happens by the SDK. It also has, since it's a very rich and graph-like NoSQL database where you can have nested structures and kind of have a structure that makes sense. So for instance, we have accounts, and accounts can have transactions, then can have credit cards, they can have, customers can have transactions and credit cards and accounts, and then you can nest deeply into that. So no schema, no problems, right? No. No schema, no new problems. So this is kind of the inevitable when you are reading and writing directly to your data store. You are bound to have incompatibilities between your clients, different clients. So we have an Android client and an iOS client, and they need to kind of write the data the same if we're supposed to be able to jump from one type of client to the next. And also between versions, how do we do schema evolutions, how do we do data versioning, and so on. That isn't handled by Firestore at all. And that's where OpenAPI specification comes in. So after a while, we saw this coming, that this would eventually be a problem if we were supposed to like create a new version of the credit card data object, or if we are to ensure that the user object is written in the same way on the Android client and on the iOS client. We needed to start defining what are the user models, what are the fields, what's the data types, and so on. So the OpenAPI specification allows us to kind of like using YAML, which everyone loves, to create, this is how the account V1 should look like, this is how the credit card V1 and V2 should look like, this is how payment should look like, and all of the different objects and data types, or objects that we have in our Firestore, and kind of create objects or definitions of them. And then from there, we can generate iOS client library, Android client library, Go library, and Node.js library, and just consume that without having to worry that is this writing this object differently than the other clients. Which leads us to the applications themselves. Both the Android client and the iOS client are, of course, native applications. It's kind of like this is our equivalent to a brick-and-mortar shop or store. So, of course, they have to be built with care and from scratch and using the native implementations. So the Android app is written in Kotlin. The iOS app is written in Swift 5. And then using Gradle and CocoaPods and so on. Both of them are using CircleCI and Fastlane for deployment, but of course, like the Android app ends up in Google Play Store, and the iOS app ends up in TestFlight and then in the App Store. So that was the Firebase part. And the second part for why we chose Google Cloud was their Kubernetes offering. So how many in the audience here use Kubernetes? And how many use it for production? Yeah, quite a few. Cool. So it shouldn't come as a surprise that the most stable and the best place to run your Kubernetes cluster is on Google's own offering. And that comes since they have 15 years kind of ahead of everyone else, because they sort of invented these not only Kubernetes, but the lower levels abstractions or functionality in the Linux kernels as well. So kind of they had an advantage there. Azure is catching up, and Amazon is probably catching up as well. So we'll have to see how the market is in 1 year's time. So I won't dig in too much why or what Kubernetes is. I guess most people here know what it is. It's Greek for the helmsman, hence the wheel in the logo. It's a container orchestrator, so when you have only one machine and one container, it's fine, but what happens when you have 1,000 containers on hundreds and different machines? How are you going to manage that? It's based or mirrored on Google's internal system called Borg. It runs in the cloud. It runs really well on bare metal as well. We have several customers using either or there. And it also supports multiple container runtimes, as well as Windows containers, for those of you who are crazy enough to do that. So, but the beauty of Kubernetes is that it gives you this API. It's mostly an API. It's actually only an API. And it doesn't matter if it's backed by a huge Kubernetes cluster with hundreds and hundreds of nodes and petabytes of memory and TPUs and GPUs and so on, or like I have in my spare room, I have a rack of Raspberry Pis. It's still the same APIs. It can't run that many containers, but it's the same API nevertheless. It doesn't matter if this is on AWS or Azure or Google Cloud. All of them has certified Kubernetes runtimes. So you just click the button, or you just call the API or use the CLI, and boom, you'll have a valid Kubernetes cluster. And of course, there are some values add the different providers provide, but the Kubernetes actually has a conformance test with a couple of thousand tests that the providers has to run, and anyone in the audience here, anyone using their service, should always also be able to run the conformance test to see that it is actually compliant with the Kubernetes specification. And they have to recertify this for each new version in order to kind of be able to call their service something with a Kubernetes name. Yeah, so API first. It's very modular. All of the components are, in fact, microservices. All of the components building up Kubernetes. And the third thing that's really, really important and why we chose it is this self-healing capability. So if you configure your application correctly, you can be able to sleep at night. Of course, the job is still on you to kind of set up the correct health checking and liveness probes. And then Kubernetes will do at least the heavy lifting. And if things fail, even though, then maybe the whole world is failing. So, yeah. So that's Firebase and Kubernetes Engine. So we actually had to split these two up in different projects within Google Cloud. So projects are like accounts. They're different, like separated namespaces. And that was mostly due to limitation for controlling access, to giving users, not the customers access, but like developers access. Be able to like go in and use the Firebase products. It required them to have all sort of other access that we weren't like very keen on giving. So we split these up Google Cloud has very nice, where authentication is just seamlessly working between different projects, so no big deal. So, but like, this is the very, very simple architecture. Of course, it can't be that simple, and yeah, you're right. So we do have some functions as well. As I kind of alluded to, Firebase has this really nice integration where you can have pieces of code triggering whenever something is changed. So you can have functions and you can attach triggers to them and say that if this object is updated or there's a new customer here or a new transaction there, run this code for me, please. And ideally, we would like to use the PubSub functionality in Google Cloud. And ideally, or initially, we did use it, but then compliance started asking not nasty questions, but they started asking the hard questions that they are paid to do. And asked us, where are the data living when you put something on PubSub? And we said, well, Google says it's globally. It's somewhere on planet Earth. And compliance came back and said, that ain't good enough, obviously. So we had to find some alternative, and we ended up with Nuts. So Nuts is a high-performance messaging system. It, of course, offers the publish and subscribe pattern, where you just like send a message and forget about it. But it also has a subscription-based, topic-based subscription system as well, where you can subscribe to a topic, and you know that if you go down and you come up again, that you'll be able to like continue where you left off without missing any messages. And of course, that's important for our customers. If they like put in a new transaction or a payment, of course they would like that to actually be carried out and not just end up in limbo. What's very nice about NATS is that it's a single binary written in Go. So it's very operational, very simple. So very little things that can go wrong, or libraries that are not the correct versions, and yada, yada, yada. It's actually quite a number of years old. I wouldn't say very old, but when I looked back into their release history, I found commits and release in 2013. So that kind of gives them some credibility to not just like going away. They are also an official CNCF project, so along with Kubernetes and Prometheus and Linkerd and Envoy and so on, NATS is there as well. And actually this June, in the beginning of June, they released the version 2.0 of the NATS streaming system, or the NATS system. So then we started looking into how should we like run this, because like until that time we kind of like, okay, all of the infrastructure part that's managed by Google. We just have it as a service. Then we started looking into the Kubernetes operator pattern, which is a way of building Kubernetes native applications. So this isn't something that we had to do, but we were leveraging it. So it's two things. It's extending the Kubernetes API. So the Kubernetes, for those of you who are familiar with Kubernetes, you have your pods, your services and deploys and ingress and so on. But you can extend this with your own API objects within etcd and the Kubernetes API. So that's called custom resource definitions. And then if you have this custom resource definition, Kubernetes isn't managing that. If you have some API object, Kubernetes doesn't know how to handle that. So you need a service or a deployment within Kubernetes that is actually able to handle that object. So that's called a controller that runs inside Kubernetes. And then you can do something like this. This is the for the Prometheus operator, if you have installed the operator, it extends the Kubernetes API, and you're able to just say, I want a new Prometheus instance. It says API version monitoring coreos.com/v1 and kind Prometheus. And that isn't like a base or a normal Kubernetes object. That's these custom resource definitions. And the Prometheus operator controller will handle that and then create the necessary pods and services and so on that will ultimately end up as a Prometheus deployment. And it's very suited for these, when you go further than what typically Helm or Ansible will do, where they just deploy it and then it's over. It does all of the life cycle. It handles upgrade and recovery. It's built in if this starts failing, how should it start restarting and data migrations and so on. So it's very well suited for complex applications that cannot be defined just by a couple of lines or 100 lines of YAML. So the NATS operator or the NATS installation that we ended up with looks something like this. We have installed the NATS operator. It extends the Kubernetes API with the NATS custom resource definition. And then there's a NATS operator controller running in its own namespace as a deployment and as pods. Then we can go ahead and say, we want a new NATS cluster. So that's a new data type, new API type in the API, since we have extended that. NATS, the operator, will then create the deployment as we have specified and create a service. So we are able to kind of reach it. Then we want to deploy an application that wants to consume this NATS cluster here. So we start off by defining a NATS service role, which enables us to kind of go take a service account and then give it some permissions within NATS. So we want to have a secure way of authenticating our applications to the NATS message bus and what actions they are allowed to do that. So the operator will then, based on the service role that we have provided, it will generate a token that has those privileges. And then we can, of course, do our actual deployment, and it's able to talk with the NATS cluster. So then we were stuck with this. So we had, when something were changed in Firestore, it triggered a function, and if that function had to call our backend services, it had to go through the message bus. And remember, this is no longer PubSub, it's NATS, and it's running inside our Kubernetes cluster. So it's a little bit wrong in the picture here. But the functions don't have access to this because the functions are running globally on some other subnet and IP that Google controls. Our Kubernetes cluster is running inside our own VPC. It's private networked. It's not accessible from the outside as it should be. And hence, NATS is not accessible there. So first, we thought of, we found this serverless VPC access connector, which acts as a gateway, which enables functions to pass through this gateway in order to kind of access not only Kubernetes services, but VMs and so on running inside of VPC. We then also had to we would have done some VPC pairing because functions are not yet available in Europe North, where our main applications are running. It's running in West 1 because that's the closest place that has these functions. And then we realized that the serverless gateway was only accessible in the US. So we couldn't do anything of any of this until I think it's Q4 when this is coming to Europe. So for the time being, we had to revert all of that. We had to expose nuts via load balancer. Had to put on, that was in place before, like client certificate and server certificate, so both parties are authenticating each other. And in addition, we have the NATS token that I previously talked about for that our backend services uses as well. So it's pretty strong authentication and authorization guarantees, but we would ideally like to have this like only inside our private networks. So then we started also asking ourselves, what if we could run serverless functions inside Kubernetes? And actually you can. It's called Knative. It is serverless containers on Kubernetes. It's an open source project built by Google, IBM, Red Hat. I were fortunate enough to have lunch with them during KubeCon. They're extremely smart couple of guys that are working full time on this project. It runs on top of Istio, for those of you who are familiar with the Istio service mesh. It has 3 parts. It's this build component that takes source code and makes it into a container image. So all of the build, you don't have to use Jenkins or Travis or Soko CI or whatever. You can just build this inside your Kubernetes cluster in a secure and efficient way. It has the serving component that enables you to quickly run up some image and then spin it down when it's no longer needed. And then the eventing component, which is a general eventing bus, and they have implementation or eventing specification, and then implementation for different eventing systems. So you can have a Kafka topic, and then you can have a serverless container spinning up, acting on that, and when it's done, it terminates and it scales down to 0. You can have PubSub. You cannot have Firebase. Because that isn't supported, and it's its own eventing system. So currently, it wasn't really a possibility yet, but hopefully, maybe it will be. And actually, Kubernetes or Google has a managed service for this inside in their offering, as well as with Istio. They have a managed Istio installation. They also have a managed Knative, and they have managed to call it Google Cloud Run. But it is Knative. I was assured about that. So moving on, our backend services, 99% of them are written in Go. It's APIs and functions, and it's services running in our backend. So whenever you have a new transaction or a payment, or we are fetching data, or whatever we are doing, that's a Go service or Go binary that's doing that work. We have some synchronous calls within our backend that's implemented as gRPC. And in some cases, if we have to expose this even further out, it's REST. But we like to use gRPC. And I'll get into more why we chose Go, but there are no frameworks involved. This is just like using the Go standard library that's there, and of course, like SDKs for talking with Firebase or with NATS or whatever, but no fancy or complicated framework on top of that again. And then we have some Node.js running as well. It's mainly for the Builderbank Anno and some functions where the SDK for the Firestore only has support for the in the Node.js SDK. We are try to be very rigorous, adhering to the 12 factors that's originally developed by Heroku. I won't go through them, but kind of they are still as relevant today as they were when they initially thought of these. I think most of the people in the audience will know them, or they are adhering to them, either if they know them or not. It's becoming more and more standard procedure. So why Go? None of us had any experience with Go when we started. We had absolutely not written any, at least not in production or for any system. Maybe some of the guys, I had like experimented a little bit myself, but not in any like big way. It was mainly, well, it delivers like best of both worlds. There are no runtimes that you need to install and upgrade and yada yada yada. So there's no JVM, there are no Python interpreter, no Node interpreter. Still, it's memory safe, unlike C and C++, where you can have all of these memory issues. It actually builds in its own runtime when you compile the application, which is very quick and efficient. And you get a static binary that you can actually cross-compile on all different targets and then just move around as you like. Concurrency is built in as a first-class citizen, so they in the Go mantra or philosophy, they have been very explicit that multi-core is kind of like the way forward, and your application should be able to kind of take advantage of that without doing very fancy or unsafe threading things. That should just be managed by the programming language. Also, it aims to reduce the amount of typing. You can see the example here is just like the shorthand version of declaring a new variable and its value. So this creates a new variable with a type integer and value 42. And it just inheres, it knows, the compiler looks at what value you are giving it here. It can be a new object or whatever it is. It knows the data types, and then it creates the appropriate type for the new variable you are creating. So this isn't like where in Node where you just like have a variable and it can be anything. And also, and this is kind of one of the more controversial things and kind of makes people like not like Go ideally or initially, is that you have to deal with errors. Errors are common, they happen, you have to deal with that. You cannot just like throw it or like, no, this is someone else's. Someone else have to deal with this, which ends up with not being dealt with at all, and you have all this fun uncaught exceptions errors. So in Go, you have to deal with them, and you have all of these. And it doesn't look that pretty when you first look at them, but after a while, you just get used to that, and it works really good. So this is a typical service. If we have something that are running and accepting synchronous connections, there's like a very simple main function that pulls in the different controllers, and you just like, handle request on this path, on this path, and this path, and then start listening on port 8080 and all interfaces. So this is built right into the Go standard library. No extra framework required at all. So we have a fairly, otherwise a fairly typical software delivery pipeline for our backend services. All changes, of course, have to go through Git. We are using Circle CI for all the build and test and deploy for our backend services. Once it's pushed, Circle CI starts chugging along, fetching and installing all the dependencies and building the application, then running all sort of the unit test and integration test and whatever you have, with syntax linting, of course, using SonoCloud for source code scanning. So the code that we write, we have some rules, and we have we want to have the quality there as good as possible. So we're using SonoCloud to kind of go through and check that. On the fly, whenever you propose a pull request, SonoCloud will do the scanning. And we use Snyk for dependency checking or scanning. So all of the dependencies that we depend on, either it's Go modules or it's NPM packages or whatever you have, Snyk will always check the versions and check their vulnerability registry, and then it will give you a report. So whenever you do a change, it would check that you are not introducing new vulnerabilities. And if there are something that is discovered, it will automatically propose pull requests. So we believe that we don't have a very large or any security team. We don't have an operational team. We rely mostly on tools that need to do this work for us. And whenever there are something that needs to be fixed, the tools should propose that and not give us 300 lines of a PDF where we have to go through and look, oh, it's this module that we have to upgrade. And the last stage, of course, is deploy. So we build an image, we sign it, we put it in our registry, and then we use Helm to do deploy to first test cluster, and then if everything looks okay, then we promote that to our production cluster. And it's the same image that is running in both. So we build it once and deploy it many times. Yeah, no cuts, no buts, no coconuts. There's no shortcut. You can't like, oh, I just need to fix this in production. No. Ain't gonna fly. You have to go through Git and then deploy. So we are master branch should always be deployable. That's our mantra. And using feature toggling in order to selectively turn unfinished functionality on and off, and working on improving that and making the business side more responsible for when a functionality should be available and to what customers. So last time I checked, we were well above 250 hours build hours within Circle CI. So we try to use. We don't want to have, as you said, we are 15 technicians or developers creating Builderbank, and we then we are then using the computers for everything. They are cheap, humans are not. So whenever there's like a boring, repetitive things that takes some minutes, that is something that the computer should do. And kind of like this is where the rest of the team are. It's build hours in Circle CI or in Kubernetes. So. We are so this is how far we were with here. We have our applications talking with Firebase, triggering functions in Cloud Functions, going through NOTs, and our backend system in Kubernetes. And then, of course, we do have some endpoints that are not cannot go through this asynchronous loop here. Either it's before the customer is a customer at all, and they are in the process of actually registering, or they need to get the token in order to communicate with Firebase, or if we have some APIs that are not well suited for like this asynchronous communication. And because, as I mentioned initially, like we want to have the best mobile experience. We want to have very competitive loans, and we also want to deliver a lot of value adds on top of the regular like banking functionality that you kind of like are used to. And that is where our partners and integration comes in. So we have a lot of partners working with us, or we are working with them, in order to provide their APIs and their functionality and enrich the bank functionality that we are delivering. And some of them needs these more synchronous communication in the way that they are designed. So in those cases, we are using Google Cloud Endpoints, which is an API management service by Google Cloud. So as you see, we try to use as most managed services as we can get away with. It has built-in support for JWT authentication, which is the same authentication system that Firebase uses. So when we have an authenticated user in Firebase or communicating with Firebase, we can also authenticate this via the Cloud Endpoints API gateway. It also have API keys, so if there's like other people wanting outside of our users that are supposed to access these APIs, we can provide them with API keys. It's very low overhead, less than 1 millisecond when we did our checking. And it comes with all sort of logging and monitoring built in. So we don't need to kind of build that on top as well. So as I'm kind of like alluded to or mentioned, we really don't have an operational department. It's not like we are building this and then someone else will do and go and manage this system for us. It's the developers that are on call, and we are really taking a lot of inspiration from the site reliability engineering and the site reliability workbooks written by the SRE team at Google. These are the DevOps principles that we kind of adhere to with automation and working lean and monitoring and a culture of sharing. So all of everything that is set up and run on Google Cloud is, of course, set up using infrastructure as code. So everything is defined using Terraform in Git, and this is an example where we have for container cluster, where we have the cluster definition and we have the worker nodes. And as you can see, it's defined in Terraform configuration files, and you can check this into Git. You can use the workflow that developers are used to, and it's working very, very good to do a review, validate that this is actually working, and then do a deploy first to our test environment and then to our production environment. And as we go along there, we have actually started creating I wouldn't say approved, but packages to make it easier for the rest of the development team to just like, oh, I need a database this, or I need a load balancer that. We have already made Terraform modules in order to make that as easy as possible, and they just commit the change or the new instance of it, and then it gets reviewed and approved, and then it gets rolled out. So it's no like they don't come to anyone and like, oh, I need this. It's them proposing changes. So for, of course, with all of the automation and everything up and running, we do need proper observability to be able to kind of sleep at night and know that this is actually working. So this is more than monitoring. Observability is these 3 pillars here. So we have, of course, your unstructured logs, where everything that is happening in the application is just sent out to std out or std error. That's fine, but to any one of you, if you have ever like parsed Splunk data, that's a terrible or that world of hurt. So where we in order to get actually metrics, what is actually going on, and reporting and alerting on that, that's where we build in metrics into the systems. That's aggregated data about how many logins, how many failed logins, what's the different status codes for this API here, how many transactions, and so on, as counters and different data types there. And then the third pillar in observability is tracing. So when you have a lot of microservices communicating and working in junction, how do we actually see that where the problem is? It originated here, but it's observed over here. And how do we trace back that transaction? So we are currently heavily using Prometheus. All of our backend services are instrumented, and alerting and all of the dashboarding goes through Prometheus metrics. We have our logs in Stackdriver, and we, of course, get data and metrics for all of the products and services that we are using on Google Cloud directly from Stackdriver. No need to reinvent that. And we haven't come as far as we ideally would have liked on the tracing part. The plan was initially to use OpenCensus, which Stackdriver has very good support of visualizing traces and spans. But at this year's KubeCon, it was announced that the OpenCensus and the Open Tracing projects are merging and becoming OpenTelemetry. So we have just like waited a little bit on kind of getting started with that when the SDKs for Go are ready. Yeah, so we went from ID to production in just 10 months. I think that was an incredible engineering effort, and our leadership, and also like the leadership, were listening to what we suggested and put us in charge more or less with how we were supposed to, or how we were delivering this. We are building on shoulders of giants. We are using services and purchasing services wherever we can, so we don't have to reinvent the wheel every time. We, of course, are using the API, banking API backends from SpareBank Invest, which is the core banking infrastructure, and otherwise building everything using Kubernetes and Firebase. So with that, are there any questions? I don't see any. I can't see. Yeah.
Do you keep your Terraform in one repository, or do you distribute Terraform across the...
Yeah, good question. So the question was if we have one Terraform repository or multiple. We have two. That's because we have some services that are shared between the different environments. So for instance, we have one container registry. We have one main DNS zone. And some storages, remote storages for the Terraform configurations. And then we have the other Terraform repository is for the actual environment, which is identical between the test environment and the production environment, just different configuration variables. Yeah. Well, thank you all for coming, and just feel free to ask me any questions about Google Cloud or Kubernetes or whatever you have. I'm very happy to talk with you about all of these technologies and much more. Thank you.